This is episode number 792, our In Case You Missed It in May episode. Welcome back to the Super Data Science Podcast. I'm your host, Jon Krohn. This is an In Case You Missed It episode like we've been doing in recent months. This one highlights the best parts of conversations that we had on the show last month in May 2024. We begin with episode number 785, where I interview fellow YouTuber Dr. Luis Serrano. Luis runs Serrano Academy, and they recently partnered with deeplearning.ai to create a course on semantic search and large language models. To understand semantic search and LLMs, we need to understand embeddings as well. So in this interview clip, Luis talks to me about what embeddings are, how they function, and how essential they are for running semantic search queries. Let's talk a bit about semantic search more. Let's dive into embeddings more. So how would you describe embeddings and say, how semantic search differs from a traditional keyword search?
Yeah. Great question. So to me, embeddings are the most important objects in LLMs. And I would go as far as saying in many fields in machine learning is the most important object because it's really where the rubber meets the road, right? Like it's where we translate our language to computer language. Computer language is numbers and only numbers. And so if we're working with embeddings, we need an image embedding that turns into numbers. If we're working with text, we need a text embedding that turns text into numbers or sounds into numbers or anything we want, we need an embedding. And if that embedding is not super strong, like you're not doing anything, right? So the better embeddings get, the better LLMs get. If somebody comes up with a better embedding tomorrow, believe me, all the models are better because it's just a better way to turn text into numbers. So some problems that were hard 10 years ago, like classification, now are much easier because embeddings are better. And what's an embedding? An embedding is just you're literally associating your text or your words to a bunch of numbers. So a vector, like a list of numbers. I like to see them graphically. So I like to imagine, I always bring everything down to the simplest example. So I like to see sending words to pairs of numbers. And what's a pair of numbers? It's a coordinate in a plane. And so I imagine all the words flying around, and words that are similar get put close. So if I have an apple and a pear, they get sent to similar pairs of numbers, which is a similar location. And I also like to think as each coordinate as a description of the word. So in a very toyish example, I could think of the first one as the size and the second one as the flavor or something like that. But if you have thousands of numbers, then you're pretty much describing your sentence or your word or your piece of text in a very, very, very detailed way using a lot of numbers. And maybe these numbers mean something to us, maybe they don't, maybe they mean something to the computer, but it's really that. And then one of the things that embeddings are really useful for is semantic search. When we search, for example, if I'm going to search for I always use this example that let's say you search for visa to travel from Brazil to USA, and I want to find the and I want to find the article that has as many words as possible in common with those, and I find one that says visas to travel from USA to Brazil. It's the complete opposite. It doesn't help me at all because it's flying in the wrong direction, but it matched all the words. So that's keyword search. If I find that the documents that match all my words or as many as my words, it's decent, but it doesn't get you there because I could reorganize the words and change the meaning of sentences. That's when we use semantic search. So in these embeddings, you're locating words, you're locating sentences in a plane or in space. And if I have all my documents and they're flying around and I send the question to my embedding, then it's very likely that the answer is going to be close. So if I have embeddings are just a way of mapping of putting all the text in flying in space and then it's easy to search in that space instead and find an answer. So we've seen a lot of improvement with semantic search versus keyword search. And then when you throw in things like re-rank, for example, is very useful because see that the closest sentence to something is not the answer. Right? If you ask me a question, you ask me what color is an apple, and I answer to you, what color is an orange? Then you say, well, what the hell? And I say, well, I just gave you the closest sentence, but it's not the answer, right? So re-rank helps you actually locate the answer. with an extra training. But yeah, semantics are still it's in a great place. I've seen some great results. So yeah, I've been happy to see that.
Very nice. So I'll try to repeat back to you some of what you said. So embeddings are they allow us to have a language of computing where we speak in, say, natural language or math or code. So we represent things in that kind of form. When we want a machine to be able to do something helpful for us with that language, we need to convert it into some kind of numeric format.
Mhm.
And I love that idea of, explaining the kind of the simplest embedding would probably have just two numbers, two float values that you represent some word or some sentence or some document by, and then you can very easily imagine that in a two-dimensional space.
Yep.
If you all of a sudden have three dimensions, three numbers that you're using to describe the location of that word or document or piece of code or whatever it is, however you're embedding that, if you go from 2 to 3, then it's like imagining it in the visual world that we encompass in a 3D
Exactly.
space. And then it becomes hard for us to visualize in 4 or more dimensions, but for a machine to be able to represent this is trivial. The
Yeah.
math is all the same, the linear algebra is the same. And so uh, it's very common with organizations like Cohere to have your embeddings have thousands of dimensions. And as you're saying, that then allows a huge amount of granularity for semantic search. So we can embed any natural language code, math, whatever it is that we want to represent. It can be understood, its meaning can be understood well in this high dimensional numeric space that the machine has. And that allows it to fulfill lots of different kinds of things. So you mentioned earlier clustering, um, but I think one of the most interesting applications that we see today with generative AI is things like being able to answer your questions. And so by by using this semantic search, you can get into the right region based on the person's query, like you said, what color is an apple or something like that.
Mhm.
That can bring you to some region of that high dimensional, those many thousands of dimensions of space where everything's about the color of fruits. But
Mhm.
then once we get to that space, re-rank allows us to find a great answer to the question as opposed
Yeah.
to just some phrase related to the question.
Exactly. Yeah. Very well put.
Nice, awesome. So that helps us understand embeddings and Cohere's business model, how they're helping out the enterprise by ensuring that they have great embeddings, facilitating all kinds of these enterprise capabilities. So, what kind of experience, if I'm a user of an application that is powered by Cohere embeddings versus maybe some old or poorly trained embeddings, maybe some embeddings that I tried to make myself that weren't well made? As a user, how can my user experience? Are you able to give some examples of how my user experience will be improved by better embeddings? I guess one we already talked about is question answering.
Mhm. Yeah, I mean, everything becomes easier. The analogy I use is, imagine if you had a great book, but a really awful translation. So you can only enjoy it so much, right? Like you can only understand so much. And so a good embedding just translates your data really well into numbers. So, for example, 10 years ago, let's say we had embeddings that were so-so, or even no embeddings. Like you can just use every coordinate as a different word, and you would have a huge space. But anyway, the fact is, let's say we have poor embeddings 10 years ago, and you want to do a classification model that tells you, I don't know, if emails are spam or not. But the region between the spam emails and the non-spam emails is very, very complex. Like it's very curvy. In order to separate them well, you have to use a really big neural network to come up with a really complicated boundary. There may be problems overfitting, etc. Let's say you have an amazing embedding that picks up things so well that puts all the spam emails on one side and all the non-spam emails on the other side, and it's really a line that cuts them are plain. I'm exaggerating. I'm exaggerating. But a good embedding makes these problems easier. So you can now, I've done classification problems with like 3 or 4 examples. So you can do much better now, as opposed to before that I needed thousands of examples, a huge model. So that's just classification, but for example, clustering is the same thing, right? Like if I have a really good embedding, the clustering becomes much easier because things are located in the right place, right? So the embedding is the most fundamental thing, and many companies just want the embedding, right? Like many the tools, they're like, okay, we have a bunch of machine learning stuff. I just want your embedding, and I can do wonders with it.
Our next clip is from episode number 781 with Sol Rashidi. Sol is an executive who has held C-suite data positions across a range of well-known Fortune 100. So I was keen to learn how she builds teams that work with data. In this clip, you'll hear how important it is to her that she keeps distinct the roles of data scientist and data engineer on her teams. When you are building out teams, you keep funding for data science and data engineering separate. Do you want to tell us about that?
I think the field of data engineering is probably one of the most underappreciated spaces, and probably the one that I adore, revere, and protect the most. And I wrote a post about this in LinkedIn once. I'm like, nothing functions, nothing happens without a data engineer. I don't care if it's a digital campaign, I don't care if it's a new product launch, I don't care if you're standing up a system so that you could sell in a new market. It could be anything. It does not happen without a data engineer, because no business process can be enabled and no growth can be achieved without information. And information is derived from data. And it's all about making sure that data is in the right place at the right time for the right people. And who makes that happen? It's the community of data engineers. I only have that appreciation because a long time ago, I was a data engineer. I accidentally fell into it. I think you and I were chatting about me going into professional sports and saying, okay, I need to grow up and take on a real job. Um, I found my tribe in my community, but apparently I was a horrible coder. They were like, "You're not allowed to touch a lick of code ever again." And I was like, "Okay, so what do you want me to do?" They're like, "We don't know, but how about you communicate what we're doing, because we want to do the work. We don't want to talk about the work." And I was like, "Oh, okay." So that's how I migrated from being a data engineer to being translating to what the data engineering team was doing, and that's where I gained an appreciation from it. Moving the data, protecting the data, making sure it's of a right hygiene, the orchestration of it, the availability of it, like everything is because of a data engineer. I don't need a big team of data engineers. I need a lean and mean team of really great data engineers, and I protect them very, very much so. Because then when I hire data scientists, I don't want them doing data engineering work. Their job is mostly focused on the modeling, the algorithms, the predictions, next best actions, recommendations. It's what they can do with the information once it's in the state it needs to be in. But I don't want them playing with the mining, the cleaning, the curating, all that other stuff. So I'm very respectful of crafts. So as a data engineer, you're a master of your craft. As a data scientist, you're a master of your craft. Now, of course, like with the world of full stack developers, we have back-end developers and front-end developers. Now we have full stack, and the two have blend, and you can be a good full stack developer. But how can you really be a master of both sides of the fence unless all you're doing is learning 24/7? So I think it's very difficult. So I respect the division of labor, and I let people do what they love to do without having to do the grunt work of things that they chose not to do. So I always try to keep the two separate.
Defining a tech role is evidently no mean feat, so we spend a little extra time on this with another clip on AI roles. Taken from episode number 787, I explore the differences between ML engineering and ML ops positions with my guest and ML ops community leader, Demetrios Brinkmann. The thing that I was trying to distinguish there, which I'm not sure we got much insight into, was this difference between like ML engineer and ML ops. What do you think about that one?
Mm. So, yeah, my fault on being on muddy in my answers and going on total tangents. I digress. That's
No, that was
your
super
job.
interesting. I'm glad we got all that out of you.
So I would say that is, again, like the job title. It's so funny that you mentioned that, because an ML engineer can be someone that works on the platform and does ML ops. And it feels like that's more of what is expected from ML engineers, but it's not always. And sometimes, like ML engineers, you'll see a job posting for an ML engineer, but really it's a data scientist who does machine learning.
So yeah, so the ML engineer might, in a larger organization with enough people, might sit between the data scientist and the ML ops person. where so the data scientist might be working completely offline and training the model weights offline. Then the ML engineer is tinkering with that model, maybe writing it using a completely different library to make it performant in production. And then the ML ops person takes that production code that the ML engineer put together and puts it into production and makes sure that the way that that happens is repeatable, that there's great operations around it. And a key term here, which I think to you as the leader of the MLOps community, there's a term that you've used a few times that I think is so obvious to you, but a bit nebulous, even to me, is you said someone in MLOps is working on the platform. What does that mean, working on the platform?
That's just the velocity of being able to take an idea and put it into production. That is that platform that is there for you to go from exploration mode in a Jupyter notebook to battle hardened code that is being monitored and can be retrained. And when it starts to drift, it can be retrained. So that is what I consider the platform. Like platform
Very
engineers feel
cool.
like, yeah, ML platform engineer is another term that you'll hear thrown around. So you get a little bit of everything, I think, and that's because it is still so new that people are trying to figure out, okay, what do we need and what kind of person is going to help us get there? Let's try and create a job title for that.
Nice. So platform is kind of like the system. It's like setting up the system, setting up the operations. Cool, cool, cool. Job titles are so important for companies to know who to hire, and also those of you who want to keep your career moving at the same momentum as the AI industry. Our final clip today is from episode number 783 with Navdeep Martin. No topical discussion about using AI for good in the world would be complete without getting my guest's thoughts on tackling the climate crisis, especially as Navdeep is building a product that aims to contribute to climate tech in a major way. In this clip, I asked Navdeep how companies are using AI systems to identify best practices that help safeguard our natural environment. Beyond fly power in this particular use case that we've gone over, what are other ways, maybe get the brain cells of our listeners going on other ways that they can be thinking about AI to tackle climate change, which is probably something of concern to many of our listeners. And I think a lot of our listeners also want to be making a positive social impact with the kind of data science that they do and the companies that they start, the products that they build. So to get those juices flowing, to get those neurons firing, what are some other examples of ways that AI can be used to tackle climate change?
Yeah, no, absolutely. Prior to Fly Power, I worked with a disaster resilience nonprofit. And so what they were doing, their name was IBTS, and they were basically advising municipalities on how to prepare for a natural disaster. So in climate tech, you have the prevention kind of companies, which is where Fly Power sits. Like, can we prevent climate change from happening? And then you have the basically the climate change is going to happen. How do we deal with this? And so this is IBTS was on this other side of how are we going to be ready when there's a natural disaster. And so municipalities that they'd work with would be like towns or cities that wanted to be ready for a natural disaster in their area. And so they would engage with IBTS. The IBTS team would take 40 hours on average to produce like their initial assessment of that area. So let's say it's Fairfax, Virginia. They want to understand, hey, what do I need to do to be ready for natural disaster? There'd be 2 people producing this report. They'd be doing extensive research kind of all over the web to be able to produce this. And so their finished product was actually 26 pages of content and conducted by these 2 individuals.
Very cool. And so this was IBTS. What does that stand for?
IBTS stands for Institute for Building Technology and Safety.
Nice. Okay. So while Fly Power is doing its best, its utmost to avoid climate change happening as much as we can, there's other folks out there like IBTS that understand that the world has already warmed, and we're already seeing disastrous effects. Some regions are more impacted than others, and IBTS is looking to be able to come up with solutions to prepare regions that are likely to be affected. And so, my apologies here, but what's the the AI here is that there's a generative AI element in what they're doing?
Yeah, so they IBTS, as a part of that research effort, they would go to the county's website first off, so orlando.gov or whatever the county.gov typically, and those websites are massive, and so what they would be trying to do is ascertain how whether they had taken kind of the best practices themselves to be ready for that natural disaster. And so in addition to their website, they'd go to these other ones, they're like CDC and FEMA, and really trying to understand that particular area. And so by working with, so they came to me and said, hey, can you make this easier for us? We want to try out generative AI. We think this is a really good use case. And so we went down that path and said, okay, well, give us your finished reports. And they didn't have that many, actually. They had like maybe 10, I think it was less than 10 finished reports. And so again, this is a great use of generative AI. I don't need a ton of finished reports. I just need to generally understand the questions. So their reports were like questions, and then here's the answer, that they had produced from these websites. So yeah, taking that and being able to do that for a county, it's never seen before.
Gotcha. So this is actually, there are quite a few parallels between what you're doing at FlyPower and what companies like IBTS are doing. What's different is the underlying data that they're using for their generative AI systems and for the kinds of reports that they craft.
Yeah, no, that's right. And I think it's like this example is like kind of symbolic of what many other companies are kind of going through right now, which is, how do I store this data so that when asked a question, it picks the right thing, right? To on the retrieval augmentation side, but also what questions should I be asking? And so, and that, that's kind of the fun part. But yeah, how do you like tweak this so that it's not hallucinating, that it's not, coming up with the wrong stuff?
All right, that's it for today's In Case You Missed It episode. To be sure not to miss any of our exciting upcoming episodes, be sure to subscribe to this podcast if you haven't already, but most importantly, I hope you'll just keep on listening. Until next time, keep on rocking it out there, and I'm looking forward to enjoying another round of the Super Data Science Podcast with you very soon.